Hi, this is Math 1428, remote delivery for April 29, 2020. This content is chapter 7.2. We're talking about circles and ellipses, and this is part 2 of 2 for this day. Use these controls to improve your understanding. You know what to do, and in section 7.2, we talk about the circle and the ellipse. These are learning objectives. And as you recall, in section 7.1, we talked about the parabolas. And today we're going to talk about the circle and the ellipse. And the circle and the ellipse really are one and the same because a circle is a special kind of ellipse. Here, the plane intersecting the cone is parallel to the bases. So we can define circles as we did before. Where we had the standard equation of a circle with center hk and radius r was given by x minus h whole squared plus y minus k whole squared is equal to r squared, and of course the picture looks like this. Or we can define it geometrically, where we say a circle is a set of all points in a plane. It does fit in a plane that are at a fixed distance called r from a fixed point, the center of the circle, which is in the plane, and the circle again is the red set of points. So here's an example. We have a circle given. You want to find the center and radius and then graph the circle. Well, you have to complete the square twice. You complete the square on the x, and you complete the square on the y, adding the same thing to both sides. And so once we've done that, we will have x minus 8 whole squared plus y plus 7 whole squared is equal to 81. That tells us that the radius is 9. And the center is going to be 8 minus 7, and we can graph it in this way. And if you want to try an exercise to test your understanding, here is a good one. You know what to do and how to do it. You can also use a graphing calculator with this, but realize you have to graph both the top and the bottom separately if you're doing it this way, and you have to be mindful of your limits of the windows, but you can get a picture that looks like this. Let's move on to an ellipse. An ellipse is different. An ellipse is the set of all points in a plane, the sum of whose distances from two fixed points, these are called the foci, plural, is constant. The center of an ellipse is the midpoint of the segment between the foci. So here's a focus, here's another focus, and what you have is, this is the set of all points. If you add the distance from the oval to the focus plus the distance from the oval to the other focus, it is a constant. So d1 plus d2 is a constant, and you could create such a thing if you taped things down and did a string such as that. The major axis is the longest part of the egg-shaped thing, and the minor axis is the shorter part. In a circle, they both would be the same, and the center is the midpoint between the foci. So if you go through the distance formula and do the calculation, you can have a horizontal major axis like this. It is egg-shaped going horizontally, and it is centered, in this case, it is centered at the origin, and so you see you get vertices that are plus and minus a, and vertices up here that are plus and minus b. And the foci can be found by solving c squared equals a squared plus b squared. So the equation that we have then here is x squared over a squared plus y squared over b squared is equal to 1. If a is the bigger number, that means you have a horizontal axis. Similarly, you can have an egg-shaped thing like this. But here, the bigger number is under the y, and that is your clue for that. Again, c squared equals a squared plus b squared, but now these are your foci. So you see you have to determine where the major axis is and where the minor axis is from the equation. Let's do an example. So we want to find the standard equation of ellipse that has vertices these and foci this, and graph the ellipse. Now, when we know the foci are here, the foci are always on the major axis. So that means that these plus or minus 3's are going to tell us that it is going this way, that the major axis is parallel to the x-axis. And we know these are the vertices, and the vertices are the endpoints of the major axis, so we can plot those 2 points. So now we know it is centered at 0, 0 also, because that's the midpoint of the foci. And so we know it is of this form. And since the vertices are -5, 0, and 5, 0, we know that A is 5 and C is 3. So we can find B squared from this equation. C is 3, A is 5. We solve them, get B squared is 16, and that tells us we can just put 16 into this equation, but that also tells us that we go from 4 to -4. So here's the equation of the ellipse, and you could write it as with the 25s, or you could write 5 squared and 4 squared to help you graph it. You can do this on a graphing calculator too. If you want to try a problem to test your understanding, here is a good one, and you know how to do this. Here is another ellipse, and you want to find the vertices and the foci and draw the graph. So when we put it in standard form, you see we had to have a 1 over here, so we divide all the way through by 36. So we get x squared over 4 plus y squared over 9 is equal to 1. Now it's in standard form, but now I know the bigger number is under the y, so it's going to be egg-shaped this way. I know that the y is going to go from -3 to +3, and the x is going to go from -2 to +2. And we wanted to know the foci, so we can solve this equation. C squared equals a squared minus b squared, and we find out that c is the square root of 5, and the foci are at 0 minus square root of 5 and 0 plus the square root of 5. Here's a problem that you can use to test your understanding, and here are the YouTube controls. You know what to do and when to do it. Now, we certainly could shift these things. Instead of having the center at 0, 0, we could have the center at HK. And if you look at that, you see that, oh, everything works the same way, but the equation is going to be, for a horizontal major axis, it's going to be the A is going to be bigger, is under the X, is going to be x minus h whole squared over a squared plus y minus k whole squared over b squared is equal to 1. If you have a vertical axis, the bigger number is going to be under the y. It is going to be x minus h whole squared over the lower number, b squared, plus y minus k whole squared over a squared equals to 1. Again, always c squared is equal to a squared minus b squared. You do have to know which way the major axis is running. So let's do this problem. Okay, you want to find the center, the vertices, and the foci, and then you want to graph it. Okay, so first thing you're going to do is complete the square. Now we have to complete the square twice, on the x and on the y. And you see it is much easier to factor the 4 out and complete the square inside the parentheses. And over here, we just don't have to factor anything out. So when we factor the 4 out and we complete the square inside, what we're going to get is this is going to become x plus 3 whole squared. Over here, when we complete the square, this is going to become, this becomes y minus 1 whole squared. Now, here, what you added was, you added a 9 inside the parentheses, but that was times 4, so you're adding 36 to both sides. And here, you added 1, so you're adding 1 to both sides. So when you add 36 and 1 to both sides, this side you will get 16. Then you have 4, this is x plus 3 whole squared, plus y minus 1 whole squared. We're going to put it in standard form, going to divide all the way through by 16. So the resulting equation is going to be x plus 3 whole squared over 4, plus y minus 1 whole squared over 16 is equal to 1. And I can consider it in these ways in standard form. Now that tells me that the center is going to be at -3, 1, that A is 4, that it has a, the major axis is a vertical one, and it tells me that B is 2. And it also tells me, by solving c squared equals a squared minus b squared, that c is the square root of 12, which could be written as 2 to the square root of 3. And so the foci are 2 to the square root of 3 units above and below the center because they're along the major axis. So you can graph the ellipse and get this. And if you want to try one of these problems, you could try number 43. You know the controls, what to do and when to do it. Now there are important applications of these things because if a sound wave bounces off, it originates at a focus, it bounces off the elliptical surface and lands at the other focus. These things are called whispering chambers. They have these at the Museum of Science and Industry in Chicago. There are Capitol buildings that have these things, and there also are some of these in St. Paul's Cathedral. A important smaller application is you have a machine which will originate a very strong ultrasound signal at one focus. It bounces off an elliptical surface and goes and hits at the other focus. And you can use this to treat things for people for kidney stones and other kinds of things in a very non-invasive but very effective way. Also, all the planets, because of the inverse square of universal gravitation, move in elliptical orbits. So from astronomy to microsurgery to political spying, many applications of the ellipse. Now, more than ever, time is precious. Each day must count. Do the math. It will make you strong. And now, more than ever, take care of yourself and of each other.